This fan blade has gone through a long period of use and was accidentally hit while I was cleaning it. One of the blades cracked and partially broke, causing an imbalance during rotation and clearly affecting its performance. Because my old plastic welding machine has deteriorated and no longer works reliably, instead of repairing the old device, I will build a simple replacement solution to continue the work. This DIY device will be designed to be compact, easy to control in terms of temperature, and safe enough to soften plastic at the crack point. I will repurpose a power plug as a handle. The reason is that the plug has a compact design, a sturdy shape, and is easy to grip, making it well suited to serve as a housing for a handheld tool. After opening the plug housing, I will prepare a short piece of electrical wire to serve as the main conductive part of the device. Next, I strip off the insulation at both ends to expose the metal core inside. Next, one end of the wire will be split into two separate strands to prepare for the connection. Each strand will be attached to one terminal of the plug, ensuring stable electrical contact and correct positioning. Next, I will take a tire valve to repurpose it as the tip attachment for the cable handle. This valve will be placed at the outlet of the handle, acting as a mechanical connector that helps secure and align the welding tip. Now I will reattach the modified plug housing back into its original position to complete the handle body of the device. I will thread the prepared electrical wire through the tire valve to create a connection between the handle and the welding tip attachment. After the wire has been passed through, I will realign the valve and secure it at the output end of the electrical wire. Finally, I just need to tighten all the connections using screws to complete the assembly process. Next, I will move on preparing the electrical wiring to ensure the device operates more stably and safely. I choose a thicker type of electrical wire with a solid copper core, typically household wiring such as cables from medium power appliances or reusable old power cords. Next, I will connect one end of the electrical wire to the two pins of the plug to complete the power supply section of the device. The two wire cores will be separated and attached to each plug pin respectively, ensuring correct contact positioning and stable electrical conduction. After completing the connections, I will use electrical tape to wrap and secure the entire contact area. This layer of tape covers the connection points between the wire and the plug, keeping them from shifting during use. The other end of the wire will then be connected to an alligator clip to serve as a flexible contact point for the device. The alligator clip will be firmly attached to the wire core to ensure good electrical conductivity and prevent it from loosening during use. Next, I will prepare an additional piece of electrical wire with alligator clips attached to both ends to serve as a power connection cable. For the soldering tip, I will repurpose the internal core of this used battery. The graphite inside is a material with good heat resistance and stable thermal conductivity, making it suitable for basic manual plastic welding applications. Next, I will grind one end of the graphite core into a pointed shape to form the welding tip. The grinding is done carefully to shape the contact end into a more compact and sharper point. helping to concentrate heat more effectively during operation. I will install the machined welding tip into the tire valve connector and secure it firmly to complete the device. All components, from the handle and wiring to the welding tip, are neatly aligned and tightly fastened to ensure stability during use. To power the device, I will use a motorcycle battery. This is a power source with stable voltage, strong discharge current, and sufficient capacity to support a homemade heating device. One advantage of motorcycle battery is its availability and ease of use. It can also provide continuous power for a sufficient period of time during the plastic welding process. The welding machine operates very effectively, providing stable heating and consistent performance throughout the process. The heat is well controlled and concentrated at the tip, allowing the plastic to soften evenly at the intended area. Overall, the device works smoothly and meets the requirement for basic plastic welding tasks. In addition to plastic welding, I will test the device's performance with different materials to evaluate the stability of the welding tip and the power supply. The joint between the two razor blades is very strong and securely fused. The metal edges are tightly bonded, with no gaps or weak points, giving a reliable and durable connection. Even when applying pressure, the blades remain firmly in place. Next, I will solder tin onto the end of the electrical wire to improve contact quality and joint durability. When heated, the solder will melt evenly and bond to the wire core, forming a compact and stable joint. The molten solder spreads uniformly over the exposed copper strands, creating a smooth, solid connection. After completion, the solder joint has a clean, shiny surface and is free from roughness or frayed strands. Returning to the cracked fan blade, I will now use a homemade plastic welding tool to carry out the repair. To reinforce the cracked area on the blade, I will prepare several small metal pieces to connect the two broken sections. At the crack on the fan blade, I will place the small metal pieces directly onto the damaged area. Then I will use a plastic welding tool to gradually apply heat, allowing the new material to soften and bond firmly with the existing surface. After the reinforcement is completed, the repaired area becomes more rigid and stable. The crack is fully bridged, and the added material forms a solid bond with the original surface. The surface looks more uniform, and the structure feels stronger and better supported than before. Now I will restore the missing parts of the fan blade, filling in the damaged areas to bring it back to its original shape. I will line the underside with tape. I will use super glue combined with baking soda to perform the repair. The super glue acts as a fast bonding adhesive, while the baking soda accelerates the curing process and creates a hardened, solid filler layer. When combined, they form a strong, rigid composite that can quickly build up missing material and reinforce cracked areas. This method allows the damaged section to be restored with firm, stable structure that adheres tightly to the surface and sets almost immediately after application. After filling the damaged area, I will smooth the surface to restore a more even and refined finish. After the plastic has cooled and stabilized, I will trim away any excess material to bring the fan blade closer to its original shape. The remaining excess will be carefully removed to avoid affecting the restored structure. Next, I will use sandpaper to smooth the repaired area. This process helps level the surface, remove rough spots, and create a more uniform finish with the rest of the blade. After completing this step, the surface becomes smoother and cleaner, allowing the fan blade to operate more steadily with reduced vibration during rotation. After the restoration, the fan blade regains a more complete and balanced shape. The previously damaged area has been filled and reinforced, blending in more smoothly with the original surface. The repaired section feels firm and well supported, with no noticeable flex or weakness when handled. The bonded area holds tightly to the original material, creating a solid and unified structure. The overall structure appears solid, with improved rigidity at the repaired section. Visually, the surface looks cleaner and more uniform, indicating that the blade is now better restored for continued use. The repair process demonstrates that with simple materials and a bit of creativity, it is possible to restore damaged plastic parts effectively. The reconstructed section not only improves the appearance, but also enhances the structural integrity of the fan blade. This DIY approach offers a practical solution for extending the lifespan of everyday items, while making good use of available resources.